Hey everyone, thanks for joining us today. We are 4 members of the Datalere team, and we're here to talk to you about Snowflake Cortex in practice. That's going to include Snowflake Search Service, Semantic Views, and just touch on agents for enterprise AI. Just a little about Datalere to get started. We are a boutique consulting company, and we work with data that is across industries, and we're tooling agnostic. We pride ourselves on being partners with organizations, not necessarily vendors to sell anything. We just like to try to bring clarity to your data and help you succeed by providing insights with the data you have. These are some of our recent consulting clients. And I'm excited to go to the next slide to introduce our panelists. I'll start with myself. My name is Michelle Gaedke. I am Manager of Solutions Engineering at Datalere. I am a data engineer and love the architecture and modeling perspective of data engineering, and proud to be on this team with, especially with these three guys. I'll pass it over to Michael to introduce yourself.
Awesome. Thanks, Michelle. I'm Mike Spiessbach. I'm the manager of data architecture and engineering here at Datalere. And what that really means with what we're going to talk about today is I've spent a lot of time working with Snowflake Cortex and really digging in and getting to know how it all works under the covers so that we can share all of that knowledge with everybody today. So looking forward to our conversation. I will pass it over to Wes.
Thanks, Mike. I'm Wesley Toy. I'm a data engineer for Datalere. Worked in various industries, most recently the hospitality and government services. And I've had the chance to implement some of the Cortex solutions for some of our clients, including the Cortex Analyst, Cortex Agent, and some of the machine learning forecasting. And I'll let Rob, who's also one of our Cortex experts, introduce himself.
Thanks, Wes. Yeah, I'm Rob Browning. I'm a data engineer with Datalere, and I my bit of a background in BI, but I have really recently been focusing a lot on building AI solutions and delivering high quality AI solutions, including ones that use Snowflake Cortex. So yeah, happy to be here. Proud to be part of the team.
Thanks, guys. Just a quick agenda today. We're going to go over Snowflake AI offerings and what is Cortex. Then I'm going to pass it over to Rob. He's going to give us a little bit on Cortex Search Service. Wesley's going to talk about the semantic views. And then Michael's going to wrap up with a live app demo of a sales analytics use case using Cortex AI offerings. And if you could just put your questions, any questions you have, in the QA in the chat. We have a lot of content to go over today, so we want to make sure we have time to cover all of the content, but we will be active on the chat.
Okay, so I'll kick things off. So what is Cortex? Snowflake Cortex is Snowflake's built-in generative AI service. It kind of encompasses a couple of different things. We have the search service and the semantic modeling that we're going to talk about today. But there's a lot of other stuff in there too. And really the high level of what Cortex is it's using LLMs with your data. You can have these LLMs working privately inside of your own Snowflake environment with access to all of your enterprise's data, kind of in one place that is really easy to use. Snowflake's done a great job of implementing a lot of these different AI features that we hear a lot about in the news, so that you can use it with your own data and make your lives a lot easier. So we're going to cover the semantic views and the search service a little bit later, but there's a lot of different features that Snowflake offers in their Cortex suite of services. And here's an example of what they offer. So the first thing on here is the Snowflake Intelligence, which is really Snowflake's version of ChatGPT with your data. It's a chat interface which uses the Snowflake semantic views and search service that we're going to demo later. but really it's text to SQL so that you can have an LLM answer questions about your data. Next on here is the Cortex agents. This is, we've all heard about agentic AI. This is a workspace for you to build agents to do something with your data. It can really be anything that you want it to be, and it's kind of a low code, no code type of environment where you give an agent instructions. Snowflake has built out the framework for using these agents. And then you can give it custom code so it can actually perform an action. It can update data, it can insert data, it can even delete data if you want it to, and you write that code for it to execute. So we can not only build these agents that are much more comprehensive than a simple LLM chat interface, but they can actually do things. They can perform actions that we tell it can perform, and it can actually make some business processes completely automated and much easier to manage than having a human do it. So it's really powerful, and Snowflake's done a great job of building these frameworks into their platform and making them really easy to use. We have the Cortex AI functions. These are some of their functions that they have, which allow you to interact with AI as you're writing SQL. So if you want to generate some sort of text around the results you're getting from a query, you can use the AI complete function, for example, and there's many that Snowflake offer. And that's a whole webinar in and of itself. So we're going to move on to the next one. So there's the Cortex Search Analyst and kind of the document processing. This is kind of the meat of Snowflake's Cortex offerings. The search, which Rob will get into later, but that allows you to query and search your unstructured data. The Cortex Analyst, which is kind of founded on the semantic layer, the semantic views that Wes is going to talk about in a little bit, allows you to query your data accurately by asking it questions. And then the document processing allows you to store data or documents in Snowflake in an external stage and query the contents of those documents, similar to the search service, but without having to process those documents into a database. And there's a lot of other stuff on this slide, but Snowflake also has a lot of offerings of different LLMs that you can use. You can use models from Anthropic, from OpenAI, from DeepSeek. They have their own, I think they're called Arctic LLM models that you can use. And so what's special about this is these models are all hosted within Snowflake and they're private to your data. So none of your data is leaving your Snowflake account. Your usage of these models is not helping Snowflake train them for further use. It's really a secure, governed, private LLM that has access to your data and can make your life a lot easier. So we have a really interesting talk with you guys today. I think we have some really cool demos and some really cool topics that we're going to cover. So from here, I will pass it off to Rob, who's going to talk about the Cortex Search Service.
Thanks, Michael. Yeah, so in the grand architecture that of Cortex that Michael was just talking about, one of the pillars is Cortex Search Services, which is the section that deals with the unstructured data being pulled into and being used by your LLM calls in the rest of the Cortex environment. So what it essentially is if you have a corpus of unstructured text data, like let's say could be scanned receipts, could be invoices, things that typically would require a human to analyze and actually pull the information insights out of. By using Cortex Search Services, you're able to have a large corpus of that data, but then still have that data be queryable by the LLM. So if you were to query a data source for a particular ID or something, or the search services would effectively let the Cortex have access to all of that corpus of data that's included, and be able to find specifically any individual chunks of data out of that source. So
Rob, can I pause you for a second there?
Please.
And Michael, if you go to the previous slide, Rob, is the corpus that you're explaining just any portion of in this data bucket here? It could be a data connector to like a SharePoint site or box, or an external stage like in I don't know, an Azure container blob, would you be pointing search service at that unstructured data in that storage place that it exists?
So the queries that would be written when you create the search service, you define a so it's got to be queryable from within Snowflake. So you can query that data source, and you define that data source as the source the uh, for the search service as it's going forward. So after the search service gets created, you define the um, a table or a query that selects from the location where your data is residing. Um, and then using the automated RAG processes and the uh, hybrid retrieval mechanism that it uses, it actually will uh, get that data, pull it out into the query that you are using it in. So RAG in general, LLMs, if they don't have access to certain data, they need to be able to retrieve that from a certain data source. So if in the some cases the LLM might not have context that's large enough to hold the entire corpus of data, or it might not have been trained on data enough to have it actually give an intelligent answer to your query initially. But RAG allows you to store large amounts of information external from the actual LLM and have the LLM go and get that data. And what Cortex Search Services does is it actually helps you build that section of it. So all of your unstructured data that it might be coming from your documents, it might be coming from a table with transcripts, and it can come from anywhere, but the unstructured data itself is vectorized um, and stored in a database, which is then um, referenced and queried by Snowflake Search Services to return the relevant data according to how it's parameterized. So
Okay,
if
that
you can see an
vector
example
embedding
of it.
there, yeah, I'm interested in the hybrid approach that search service uses. Yeah, I think there's
Yeah,
an example on the next slide, Michael.
yeah. So the hybrid retrieval is one of the things that makes Cortex Search Services so nice to use. Is that uh, in a typical RAG setup, you'll have to build your own vector embedding uh, system and build your own keyword matching system and build your own re-ranking system, and then sort of string them together and hopefully get a good result at the other end. But what Cortex Search Services does is it handles all of that for you. So when you actually define the search service, um, you tell it the source data query that it's going to be refreshing, and then you tell it the compute warehouse, and then the actual refresh interval index, which is another thing that we'll get to in just a moment. But it will allow you to uh, essentially have that entire RAG process that's complicated to set up on your own. Be the stack is set up all in one go whenever you create the search service, and it automatically is uh, refreshed and handles all of that on its own um, behind the scenes for you without having to manage those separate sources. So in this example, uh, we had uh, the demo we have built is the transcript. It's a simple table that contains transcripts um, and regions where those transcripts came from. Now, in this example, we're saying the use case is search for internet issues. There in the center, you see internet issues is the query we're using. Um, what that is effectively doing is saying, give me from that table that I am defining, which is transcripts in this case, give me all of the information or give me the information that's most relevant to internet issues. And so in this case, the row that it returned is transcript text. My internet has been down since yesterday. Can you help? But one thing that I want to point out here is the filter section within the search preview query itself. So you can add, based on the data set that you are defining, you can specify filters so that your search results are handling those parameterized filters as well. And so it's a very powerful tool, and you can imagine this being used in a couple different use cases. So, an example of a chatbot that is conversing with documents for an employee handbook, for example. If an employee wants to ask what their PTO policy is like, and you have a Cortex Search Services set up connected to that document, that would be able to return that. You could also have this could also be built in as a part of a data engineering pipeline that could help label or separate out specific types of data based on some of that search feedback that comes back from it. So yeah, this takes away a lot of the manual fine tuning and a lot of the manual setup that court services that a RAG process would typically entail. But the most important part is that it's really just connecting your unstructured data to the rest of the Cortex AI environment. That's really the core of it.
Yeah, I can think of a lot of use cases where I like to get started and try this out. I'm curious on the metadata management and that attribute filtering capability you have listed out there. How much metadata management has to go into this before even, well, you can set up the search with just one line, but then do you have to do a lot of engineering around managing the metadata to get it to work well?
Yeah, so you just like you said, you can set it up without those specified, and it could be a query that just has, effectively a list of text transcriptions. But it's really going to still be important to have a good underlying, data model that you're trying to, achieve and this isn't going to, be a magic bullet. But this is certainly going to be a good place for once those things are modeled and once they can be taken out of that. Once your unstructured data and the metadata that's associated with it is properly lined up, then it just makes the process better and better as you use it.
Okay.
So it just
the power is like really in connecting your unstructured data with search service to like what Wesley's going to talk about, the semantic views and the well-modeled data, the structured data, and just being able to set this up basically in no time with all of these internally managed features that Snowflake Search has. Do I have that right?
Yep, absolutely.
Okay, awesome.
Yeah, and I think the power of this too is that we haven't been able to do this in just a database before,
Yeah.
right? In order to get this example that we have on the screen to work in a database, you'd probably have to write some really complex regular expressions. And I think everybody on here would agree, nobody wants to write regular expressions all day. So I think the ability to essentially ask it for, give me the rows where there's internet issues, it does it for you. And you don't have to go and set up a bunch of complicated and natural language processing custom code outside of the database. You can just write a query that you say, give me all the calls with internet issues, and boom, there they are. It pops right up, and with pretty minimal setup. And so it's really, really powerful, even in the day-to-day of a data engineer, to be able to identify these specific records or whatever the use case may be to process this unstructured data really quickly and efficiently with minimal setup. And so I think it's really, really, really powerful, even from an engineering perspective, to be able to process data like this.
Awesome. Yeah. I'm really excited for like the product roadmap of both Snowflake and Databricks. They're also bringing like a cloud-based Postgres transactional system in. If you can just have all of your data closer, and we always used to talk about having a unified model, but now it's more like, okay, well, what are my topics? What are my domains? How am I querying? What am I asking to really understand my data well and be able to bring all of these things together? I'm thinking of having a transactional system, ChatGPT or Claude, and then also a really good dimensional model all in one place, and the power that that could bring. Sweet.
Yeah, definitely. I think these products are really setting themselves apart, especially with their AI capabilities. And the search service is just a good example of that. And um, just this one example is it shows how powerful it can be. And searching through text data is, if you've done it before, you know how much of a nightmare it is. And this really makes it much simpler and easier to use and harnesses the power of these LLMs.
Awesome. One more question I wanted to ask you, Rob, on the setup and the compute and tokenization of your data here, of your unstructured data. What does that look like? What should we look out for from like a cost perspective?
Yeah, so the the uh, one thing I would call out there is you want to pay attention to the indexing uh, interval. So they call it the target lag is what the parameter's name is when you're setting it up. But what that is defining is effectively how often you're going to be refreshing that interval. And so if you think about what the actual process is doing when it's refreshing, it's effectively building a snapshot of that query. Um, and so whatever query you define when you're set up the search service, it creates a snapshot of it. Um, so when it does that, it's turning on a compute warehouse and it's going to be using time uh, there. And so that's going to be the one cost thing that I think is going to be pretty important to tune is if you got something that's refreshing every single day, um, or refreshing every 10 minutes or something, the target lag is going to be set to 10 minutes, going to be really short. That means you're going to have your compute warehouse turned on for a large chunk of the day. And that's going to accrue lots of credit usage there. Whereas if you have something that doesn't update that often, maybe once a week or maybe just once a day, you can set the lag to only do only a refresh on the appropriate intervals, and then you'll save costs from there. So yeah, and 512 tokens is about what the vector embedding token size looks like, and that is the cost usage associated. Um, yeah, I think overall that is. I just would pay the most attention to to the target lag section, I think, and that refresh interval would be the
Okay.
most. Obviously, larger corpuses of data are going to take more compute whenever
Yeah.
you're indexing
More
them.
tokens.
So
Yeah.
just be aware of that. Yep.
Okay. Awesome. Um, yeah, well, that was a good overview of Cortex Search Service and unstructured data, the uses there. Next up, we'll have Wes talking about semantic views, the structured side of things.
Thanks, Michelle. I just kind of want to talk about your point. You want to have like a Claude or a Chat GPT connected to your enterprise data, right? But the core problem is that the way that a business user, say a business analyst, thinks about their data may not always translate well to how a someone on the back end thinks about the data. So just a simple example, uh, if I'm a sales company, if I'm a data warehouse engineer, I get my sales data in and I expect revenue as a column on a single table that, may not actually have a lot of value. It might say like AMT underscore TTL. But when a business analyst or an executive thinks about revenue or total revenue or sales, they're expecting the same figure, but maybe it's without discounts or maybe it's net of any returns. So just addressing that gap between how business analysts think about data versus how the data is fundamentally structured on the back end is where semantic views come to play. So they act as that bridge to to unify the physical tables on the back end of how the data is actually structured and transforming that into an authoritative definition of how business analysts think about their data. So that way, when I'm having a conversation with an executive or when I'm having a conversation with, my engineer, I can say my total revenue isn't looking right for the day. They know that how to trace back that definition back to the source system and how that source system should be translated properly, go through the proper cleansing steps, and go through the proper definitions that we've all agreed upon. So semantic views act as a really good tool to kind of start that governance discussion between the business analysts and the engineers. And it can act as a really good tool for just defining your business definitions of your data in a one-stop shop. And then that just helps with the AI applications because now when I ask a question about my data, it doesn't necessarily have to be in the exact same way that I would have to write it in a SQL query. I could say, I want to see total revenue for the day. I don't have to know that total revenue actually comes from a aggregated metric of amount underscore total minus discounts. So that just really hammers home that gap between the business use and the technical use. So acting as that abstraction layer between the two. And we've seen this in a couple places, but it really should be that authoritative definition, and that really can drive the BI consistency. So once we have the semantic view set up, once we have, then we can have our BI analysts and our BI engineers kind of reference the semantic view and write their measures, metrics, and filters all driven off of the semantic view. So that way, when I'm building out a report, total revenue for this day looks the same for another team that builds total revenue for a different region. And as you know, I'm sure we've all seen the disconnect of different teams, different businesses. They say total revenue is one thing for one day, but if I look at another report, it might be a different thing. So just really having that unified vision of how we think about our data is where semantic views come to play. And a great thing about how they're offered in Snowflake Cortex is that they're schema bound. So that means they're treated as first-class objects within Snowflake. So that means I can write DDL against it. I can add comments on it. And a really good use case of it is, let's say I'm developing my dev environment. I build out my semantic view with all the definitions, all the synonyms on my facts, metrics, dimensions, filters. Once I've agreed upon it with my development team, it's as simple as porting it over into my production environment, given that the core data model is the same in production compared to the development. So that's a really great thing about how they're used in Snowflake Cortex is that they are treated with that level of consistency. So you also they can be governed well with their permission. So if I only want my analytics team to be able to edit and describe how a metric should be defined, they can have access given their Snowflake role. And if I have a business analyst reader role, they can query it but not make the changes. So that really allows for that governance perspective.
Awesome. Yeah, I'm seeing again a lot of use cases here with especially working with a lot of structured data as a data engineer. Just could you imagine if for every domain in an organization we took the time to define these business rules in the semantic view, have that governed by like some kind of Git tool, and then have this Cortex analyst who's going forward just doing that translation text to SQL, having those verified queries well defined and providing accurate results. Like, don't tell Wayne I said this, but do we even need dashboards anymore? This is going to be, yeah, I would like to see this at an enterprise level across an organization. used for many different domains. I think that the answers they could get by having this set up correctly would be so powerful.
Definitely.
Yeah, did you
Yeah, and I
have
think I'm going to hop in quickly, Michelle. I think anybody who studied data modeling in college or grad school has probably read about putting together a semantic model as part of the data modeling process. I think we've been talking about this for 30 plus years on building out this semantic layer as part of the DW, the analytics type of implementation. And now we're actually seeing why and how powerful it can be. And I think Power BI naming their data set semantic models has kind of thrown a lot of confusion out there around what the semantic layer actually is. And this isn't a talk about the semantic layer, but really what we're doing is we're building a true semantic layer on top of our data warehouse or our data sets that we use for reporting. And we really want to be in tune with whoever built the model, whoever is on the governance team to make sure we have all of our terminology aligned with how the business talks about data and uses data so that when we are using this in an application like we're going to show later, the semantic views is able to communicate using our own business terminology, not terminology that might not apply to us. So I think it's really powerful when you build these semantic views um, to make sure that there's a lot of people involved because this really is a core layer that is really important in a modern data architecture.
yeah, so that Power BI, they renamed it to Dataset now, I think, but yeah, it used to be called Semantic Model, Power BI Semantic Model. That's more of like the reporting or um, consumption layer. What would you call that?
Yeah, it's really a virtualized analytics layer. Um, and it really is not a semantic model. I think
Mhm.
you're not necessarily defining all of your business terms inside of your data set in Power BI. You're really um, presenting the data to a reporting tool in a way that it can understand it. And
Yeah.
so what we're doing here is different. We're really defining what our data is so that these LLMs are able to understand what we're asking when we actually use these semantic views.
Yeah. Okay. So not only the structure and the relationships, but also the language, the synonyms, how the users are thinking about the data versus, this is how I'm going to query it with a specific tool like Power BI.
Yep, exactly.
Right. In an ideal scenario, the semantic view happens before we build out any reports, and not a siloed process where, we have our data engineers in one function bringing in the data, and then our business analysts defining the definitions of what they think total revenue should be. It should be a collaborative process where everyone has a general understanding of the business, and we're having a discussion of where total revenue comes from. Is that less a certain column? Is that what are some synonyms for it? So really having that collaborative process before we get to any of the reporting layer, because when we build out just to use Power BI as an example, before we build out the semantic model and the measures, those should theoretically be the same as what we have in our semantic view with just, maybe some date filters, maybe some other dimensional filters on these measures.
Awesome. Okay, I think you had one more slide, Wes, on the semantic views.
Yeah, this is just an graphic from Snowflake, but just another way to think about how semantic views fit into everything. So we have, our data coming in from all these various sources, and it doesn't matter if you're using like a medallion architecture or a zone-based architecture, but these semantic views really sit on top of that final layer. So whether it be the gold layer or the analytics layer, after you've transformed it and you've got your data well modeled, the semantic view sits on top of that, and that's where you start having the discussion of what the business terms of your data actually mean. So that way, an AI tool can use it. That way, it can be that authoritative definition for your BI tools, and then you can, when it writes the text to SQL, it knows when I'm asking about a certain metric with a certain filter, where it should get that data from my gold layer.
Right.
And then this is just um, another view of how you can get started with semantic views. So it all starts at the top with a really good data model. If you provide, if you provide ChatGPT or Claude with terrible data, you're going to get a terrible output. It doesn't matter how well you define terrible data. Like if it's not modeled correctly, you're just going to get bad answers. So that's how it all starts. And then moving forward is what I was talking about previously is the logical mapping of the business concept. So from my gold layer, I have my physical tables that I've got in my Snowflake environment. And then I'm going to build a logical table of how to think about these business concepts and entities across my gold layers. So that's building out relationships, facts, dimensions, and filters. So in our app demo that we're going to show you, we have a sales data mart. So we have customer, product, date, and then our transactions table. So building out how a customer relates to a transaction, or what is order date, what is ship date, things like that, and then providing those synonyms on top of all the attributes a within the business concept. So total revenue is the same as total sales, and that's, like I said, it's this one fact column minus discounts, and without any returns. And then at the final layer is these verified queries. So that's after I've got all of my business concept mapped out for my data model. It's really thinking through of like the common core questions that our business is asking about our data. So as I've been reiterating, what is total sales for the East region last year? And that really provides specifically when we're using a AI application, it provides it some of that Cortex search functionality of a query that is similar. If someone asks what is total revenue for the West region, it's able to use that verified query to pass in as context. So that way it knows the correct dimensions to hit, the correct facts and metrics to aggregate that are semantically similar to a question that is similar that is asked. So that really helps improve the accuracy of your results when you're doing a text to SQL functionality, and it will just make your answers better when you're chatting with your data.
Awesome. I think now, well, I'm excited to see us in practice setting up. Well, I don't know if we'll go into the setup too much, but Michael, if you hit the next slide, I think we're back to you with the demo.
I think that's what we have scheduled next. Yeah, so here's a quick screenshot of what our demo application looks like. I'm going to quickly switch over the screen share if I can work my computer to the app demo.
Rob, we lost you there for a minute.
Okay, can everybody see my screen?
Yeah.
Okay. So here we're sitting at a landing page of an application that we built that kind of utilizes both the search service and the semantic views that we've talked about today, kind of in action. So this is something we've actually implemented with a couple of our clients, and we've seen a lot of success and a lot of usage on these applications. So this application is built using a newer Snowflake service, the Snowpark Container Services, where you can essentially deploy an application to run inside of the Snowflake environment using a Docker image. So it's really flexible, and there's a lot we can do with it. And so just giving a quick tour of what we can see here. So we have the subject area dropdown. There's a couple of things we can do with this. So Wes was talking about semantic views. The semantic views are limited in scope on what Snowflake recommends that you create inside of one specific semantic view. So what we recommend is one data mart per semantic view. With that being said, we want to make sure that this application can query all of your enterprise's data. And so we can either select which subject area or data mart we want to ask questions about. Or what we can do is we can hide this and we can have an LLM that's orchestrating this process, pick which semantic view it thinks is best to answer the question. On this left side here, it looks a lot like ChatGPT or Claude or any of the other models when you're using it through the company's application. And we wanted to make this app feel we wanted to make it feel familiar. So a pretty low learning curve for actually jumping in here and querying your data. We can see our previous conversations. We can go and remove a conversation if we want to. And so I'm an admin on this application. There's a couple of things we can configure. So the first thing is we have different narrative types. So in the demo, in a little bit, I'll talk about generating this narrative based off of our results. But what we can do is we can, modify this prompt. We can even change the label to have different types of narrative with different tones and different themes generated based off of our results of our data. So if you were tasked by a VP at your company to produce a report and send some analysis over to them about a specific topic, you could write your question or write their question in this application, run the question through it, and then generate this narrative, and then you're done. I know a lot of us on this call spend a lot of our time working through data requests. How were sales yesterday? Tell me how this salesperson is doing. Why are sales in this region not as good or not hitting our forecast? All of those requests can be handled in this text to SQL type of application. And so we really wanted to enable users to be able to get whatever they need out of this application from our data. Semantic models. So this is what Wes talked about. We have our different semantic views created in Snowflake configured here. So if we wanted to add another one, say we have revenue now, we wanted to look at shipments of orders, we could add a shipments data mart into here and quickly add it to the context that these LLMs have. A couple of other options that I don't think we need to talk through for this demo is just kind of app config. So let's get into the meat of the demo. So we're starting off with what questions can I ask? We're defaulting this as the first question asked whenever a user starts a new conversation, and it gives an overview of the semantic view. A lot of this is defined when we create the semantic view inside of Cortex. But here we can see this is a data set that is for sales data, and it's for a company that is similar to like an Office Depot or Office Max, where they sell office supplies and furniture and electronics and maybe some software. And so there's a lot we can do to ask and get deep insights from that type of data. So we'll start off by asking it this question. These are some sample questions that we can define in our semantic view that display up here to make the user experience a little bit better. So as that's running, we can see here's my question. And then I think a really powerful tool is in this application is we're returning back to the user the LLM's interpretation of the question. And so we can use that to make sure that we're on the same page with the LLM and that it's actually interpreting what we're asking it correctly. And as we kind of walk through the different features on this app, so we see that I asked it total net revenue by product category year to date. So it's interpreting that essentially as what I said, but it's also telling me it's interpreting that as January 1st of this year. So maybe our fiscal year is not January 1st, it starts on July 1st. And so that's something we can configure in the semantic view is giving it that business logic and in the context into our specific business. So when I say, how are we doing this year? And my fiscal year starts July 1st, it will respond with its interpretation being, we're going to pull data starting July 1st instead of January 1st. We can see here that it's actually querying the semantic view, and then it's using that to actually pull the data from the underlying table. So it's It's writing its select statement here from the semantic view. If I wanted to, I could copy this and run it in Snowflake and it would run. I could go in and edit it if I want to, only if I have admin permissions. And then here, a little bit down, we see our results. So we have the total revenue for each of these different product categories: electronics, software, furniture, office supplies, things like that. What I can do is I can download this data. I can expand it if there's a bunch of columns that are returned. I can also go in and make a chart. If I was tasked with providing some analysis and making a quick visual without having to go through our visualization tool, I can come in here, build a quick chart. Here's an easy bar chart that compares the revenues visually. If there are requirements that, we need to build a complex visual based off of this, we can do all of that in this application. If we don't want to have column names as our axis labels on the chart, we can go in here in the chart options. Actually, we can go out of the chart and go here and change our column labels if we need to. And that'll also change it on this table output. And then I can also generate an analysis PDF. Like if I need to send this to my boss and provide the analysis of visual and the data, I can do all of that in a PDF. I want it to be normal page size, portrait. I can include the table, the query, the analysis, and the visual. I can configure a bunch of different things. And then I can actually export the PDF and then download it. So it's really cool. We can generate essentially a report just by asking this application a question about our data. And then lastly, what we get when we ask a question is a little bit of analysis. It's defaulted to use the academic style, but if I want to change the tone, maybe we're using our data to send out a marketing campaign to some of our customers. We can have the marketing tone applied to this analysis so that it's targeted in the action that we're wanting to take from this. And then lastly, we have the explore further section. So these are some questions that would lead me down a path to do some deeper analysis, maybe on the same question or a very similar topic that other users are also asking about. So if I want to continue my conversation, what we've done is we've provided conversation memory to this application. So just like if you and I were having a conversation about our data, so I asked the question about net revenue for product category. What if we do that for customer segment? But if we're having a conversation about it, what if I say, what about by customer segment? You know exactly what metric and time frame I'm talking about. I don't have to reiterate that to you, right? We're having a conversation with our data. We're not having a conversation with a robot or with AI, right? We're having this real human interaction type of conversation. And if we're talking, I would say, well, okay, well, now what about by customer segment? And it understands it. We can see that the interpretation of my question, what's the total net revenue by customer segment for the current calendar year to date? And it knows that's exactly what I'm asking for. And so here we see our revenue breakdown, and we can do all of this over again. Let's see. A lot of the times there are people that work with these applications that might be a little bit sneaky, might be trying to get other people's salary information, or maybe you never know what people can ask in these applications. So there are some default security parameters that we add to this. So if I say, what is Michelle's SSN? There's some guardrails around this that will prevent me from getting that information. So yeah, that's a quick overview of the power of using these semantic views and search services behind the scenes to enable users to do their jobs a lot better, right? If we can enable users to not come to the data team anymore for these simple questions and go to this application, it's going to make data teams and analysts and kind of everybody in the data space much more productive. So I think this is a really powerful tool, and it also shows the power of Cortex using the semantic views in the search service to get real accurate and performant answers to your data questions.
Oh,
We
I'm
can
glad
see
it didn't
here,
come back.
yeah, it did not come back with Michelle's social security number, so that's good.
Yeah, I was also thinking about our last webinar with Matt Schwartz and just talking about how, he doesn't want a even as an analyst, like sitting in front of a dashboard or doing all of this work just to get the report out. This allows the people who are actually using the data to get to their insights faster. I think it also allows for spreading data literacy because we do need that semantic view, that layer where we're all now talking about the data. We're all trying to figure it out in a way that we could use language to describe it, not only having that siloed in a team of people who only knows how to discuss it in terms of SQL or Python. We can now talk about it in just natural language in English and bring us to the action that we're taking so much sooner. This is really cool. And yeah, thank you guys for putting this demo together, having so much information on how to use AI within Snowflake in a fully managed capacity where the setup is really pretty simple. And then you get to focus on that part of yeah, what's our data actually look like? How are we managing the metadata? How are we defining the semantics and the synonyms? How do we think people are going to ask this question in the app? And how do we tune it to get more accurate results every time? Um, this is so awesome. I'm excited. I think we have one more slide just doing a high-level overview of each service. Yeah, fully managed. We talked about the search. Rob talked about the search and unstructured data, how it's built in indexing for RAG applications. Wes talked about semantic views, defining that language behind, bridging the gap between the language behind and having consistency in the semantics and the data definitions. And then, yeah, that app was just amazing. Also, how many times have you done a demo where it actually works out? Good job, Michael. And I hope we can follow up with another webinar in the near future, really diving into Cortex agents and how we can use this to ask even deeper questions, get to our data in ways we probably haven't even thought about yet. So yeah, thanks everyone for joining. Last slide is just if you are interested in these topics, if you're interested in speaking, we're always looking for speakers on our webinars. If you have data strategy questions, we are open to discussing them. As you can see, we're all really pumped about different ways to use data, how to structure it, how to manage it, how to get real results out of your data. So connect with us on LinkedIn, send us an email. We're looking forward to talking to you. All right.
Awesome. Thanks, everyone.
Everybody.
Thanks.
Bye.